Hello, good afternoon. So thank you very much for this slide. My name is Josep Martrat. I work in Eviden, an Atos business. And I'm going to go through the presentation of HORSE. HORSE is a project of the SNS Joint Undertaking with the main concepts and research topics that we are addressing. So HORSE stands for the Holistic Omnipresent Resilient Services for Future 6G Ecosystems. So HORSE addresses the challenge of the infrastructure operation, looking at the smart connectivity and the service management. And the focus is on the security workflows. And when we say security workflows, we will see some examples in the presentation. And we want to do this in the intersection between the connectivity on one hand, the compute resources, and the security, of course. In that sense, HORSE looks at the detection, the predictive detection of threats, trying to analyze the impact analysis of some cybersecurity threats, looking also this proactively to the breaches and propose mitigation actions to that. For doing this, we use, and you will see some technologies related and some work related to digital twins. That is something that I'm going to elaborate today, plus some orchestration and management and orchestration functions around NFV, intent-based networking for the entry point on the perspective of human in the loop, and some artificial intelligence techniques, as we will see. So we are 14 partners, and we are running now for a year, and we are in the middle of developing the first prototypes of that. When we look at the challenges at the beginning, as all projects, we try to understand and do a comprehensive analysis of the 6G scenarios through the use cases. That's clear. And what we saw is we were going to design the necessary end-to-end security solutions. And this deals a lot with the orchestration, looking at top-down and bottom-up with the different trends that exist. And in that sense, HORSE needs to tackle the security beyond the traditional solutions, because we need to use, as I said, digital twins as a part of the ideas on the research, the AI-assisted secure and trustable orchestration, proactively and reactively actions on that, try to look at the logical NFV, the traffic separation, how to do network slice isolation and analyze traffic anomalies, and in order to detect or attacks or propose the mitigation actions. And this is important because normally when we go for a new system design like 6G, normally it seems that the security part comes later, and is addressed later, and not directly sometimes in the design phase, except for some basic functions like authentication of users or something like this. So here what we propose on some mechanisms that really work, and we analyze the impact on the different models in terms of management and orchestration. We are looking, of course, other parts in terms of challenges to design a system interface to be more intent-based for more not so skilled people, this human-centric approach, and there are different parts on the analysis of the attacks. At this moment of the workshop, I would say that all trends related to 6G have already mentioned, and I'm not going to insist more on virtualization, disaggregation, cloud native, and so on. Instead, what I want to highlight is that when we mention all these trends, for instance, let's include the far edge in the control plane of the network. So the far edge devices, robots, cobots, so these elements as a challenge in the control plane. Or we go for the combination of networks. When we say these type of things and we push with the subnetworks and so on, these types, what we are doing effectively is to increase the surface for attacks that the system will have. Because we are introducing more and more complexity, and we are introducing other elements that are potentially be attacked, and this is something that we are considering in the HORSE perimeter. In terms of the usage of AI, you will see that we apply this on one hand for the AI to do the network management itself, to have a network more autonomous, to do intelligent decisions, that's clear, but also to use for the analysis or the security threat analysis and the reaction in order for the angle of the trustworthiness of the network. So 2 pilots very quickly. One is related to, let's say, extended metro urban metro case or light rail in Dublin, starting from that in a big city, not because it's the novelty. What we try to highlight the fact is that on one hand, we have critical traffic that is for the control or the operation of the trains. We have some other traffic like multimedia. We have legacy systems that are being evolved from the traditional, let's say, GSMR towards new future railway mobile communication systems, another type of traffic. In the end, this requires a combination of multiple networks that sometimes, and access networks that is belonging and offering, let's say, that is putting a challenge on the analysis of threats and security part. The other is more related to industrial XR immersive scenario extended. So it's a virtual and a scenario in which you can support in a factory, for instance, some operators with let's say, I would say that is a traditional in the 5G scenario, but what we try to do in order to push this is what if there are a multi-user collaboration and within the factory in which you have an indoor network, but you have also sometimes you have mobility requirements on this because normally these type of devices use, let's be honest, are using Wi-Fi to connect these virtual glasses and so on. What happens when there are mobility and needs to be supported by the 6G network and more enriched cases on that. Having said that, okay, we move towards the definition of the architecture. And you will say, boof, plenty of boxes, plenty of arrows, and so on. But let me navigate together on something that in the end is not so complex. But let me highlight a couple of innovations associated to that. If I do a oversimplification of the architecture, we all are familiar with, we have a lot of monitoring and data and information that is coming from the infrastructure and from multiple sources. We have, through the pre-processing part, that is the real context, what we call, in which you analyze all this data and you try to analyze and detect if you have attacks, if there are anomalies, if there are problems through the vulnerabilities that you may have. And with that, you try to react. There is another part that is one of the key points, that is this network digital twin as an emulated environment that is inserted in the decision and the orchestration part of the network. What is doing this network digital twin? So we use this to do two things. One is it's like a sandboxing environment. One is prediction and prevention of attacks, and the other is more intelligent analysis of what we call what-if scenarios if I do a change in the network. But before doing this, we can analyze this in the digital representation of the network. Of course, it's applied in several elements of this architecture, and there is the recommender and the intent base that in the end, when you make the decision, you can enforce this towards the orchestration, and you have also the complexity of dealing with multi-orchestration, different domains in order to enforce the actions that you are doing. So similarly to this, I'm picking up a slide from Hexa-X project version 1, in which it was already analyzed the management and orchestration perimeter and all the security functions that levels, let's say, in the different layers, the infrastructure, the network, and the service layer that would be required, and what type of analysis is done at the different levels, including and taking into account that this is combined with the control loops that appear everywhere and the AI ML functions that are also the models are applied everywhere too. So we have done this and taking that because we were working in parallel on that during the definition of the architecture as part of being compliant with that, looking on the cybersecurity. One point that it has been clear that we need it, and as a team is something that when we were doing the design is, okay, we need to be concrete, because for the moment it seems everything high level type of attacks. Can we pick up some of the attacks that can be associated to new trends on 6G? Because otherwise are all the attacks that may have already in 5G on distributed networks and so on. So one, for instance, is, okay, it is not new, the distributed denial of service attack, but if it is because someone takes control of the far edge devices and that this creates as a swarm an attack towards certain control elements. It could be a DNS, it could be the NTP element that controls. This really creates a problem on the control plane of the network. Other parts has been, for instance, the example of the attack about signaling problems. Whatever is the evolution of the core, 5G core functions, we all agree that there will be some session functions, there will be the user plane, and there will be traffic on that. So anything that is done towards that signaling is affecting both the data plane and the slicing associated to that. When we say also other type of attack, okay, the 6G will be more and more open. What does it mean? There will be APIs in order to gather information or do actions through the exposure functions that it has the network. Again, these are new things that are open the door to other type of attacks, and that's we have tried to be concrete because the list could be endless. If you are using AI, someone can poison your data set in order to make decisions. For all these type of attacks, we have tried to be concrete and try to apply this to our architecture in order to put this in let's say, running and understanding what are the consequences for the definition of the 6G system in terms of prediction, prevention of the security threat, and how to do the mitigation action. Coming back now to the picture of the architecture, let me focus just 2 minutes on that model about emulated context that in turn we have at this moment 2 different type of digital twin of the network. One is used for the prediction and prevention. All the monitoring data that is coming is going through the real context in order to do, let's say, the normal loop on the enforcement, on the orchestration and management of the network. But you can also use this in the emulated context in order to provide advices and recommendations towards actions in the network, because you understand that it could be a potential attack or could be an attack in certain parts of the network. And on the same way, you could use let's say the operator, for instance, could use this emulated environment in order to create what is called this what-if scenarios. In order to, if I'm going to do this change in the network, let's migrate this function from this cluster to another cluster, or I close this part of the network because it's being attacked and I need to put in quarantine or do changes in the configuration of a switch. What if I do this in the emulated context in order to extract the understanding of this? So this is from the intent-based other case that we are working. If we see the same, not to overcomplicate the things on the naming of the different components, but both the threat prediction or these what-if scenarios from the intent-based in order to analyze the impact even before you try to apply this to and enforce this in the network with the concrete actions over the infrastructure. So this is part of the novelty that we think is interesting in order to push some elements on the enablers of the 6G in that sense. And stalling one of the slides, let's say, of 6G Hexa-X-II that has been presented, all the enablers some minutes ago by my colleague Ignacio. Horst has also done an analysis of what are the relationship towards this analysis and the need that we see in order to combine multiple enablers and push this towards a standardization in order to have more secure management and orchestration for the 6G future, let's say, 6G system. Because this is absolutely necessary, and this is aligned the research of Horst towards the work that is being done in the X2. So I wanted to mention this because it's part of the analysis that we want and where we contribute these mechanisms that I have been shown about the use of network digital twin in certain analysis. All in all, just to conclude, we are introducing the network digital twins, this unboxing as enabler in order to increase the security. These elements needs to be continued feed with information, monitoring information from the topology that you want to analyze, the workloads, the traffic, what is happening with the logs, the users that you have, and so on, and doing over this emulated environment that is a reduced, let's say, mirror of what is the production part. But in that sense, we use really emulators on that, or we use certain control environments on that, not simulations. This is something that we can do for the network management. I know that we are not touching more the radio, or we are not touching, the perimeter of the project is when functions are virtualized and you can control and can be orchestrated. So in that sense, with the network digital twin that is as an isolated, you can play a lot of the scenarios and also use the intents that we introduce intents in order to relate this, to have this human-centric or human in the loop when you want to create scenarios about cybersecurity challenges that you are facing in the network. That's a very brief part of the project. We have other parts related to multi-domain orchestration, how to enforce certain functions, and so on. Thank you for your attention, and if there are questions, we will pick up in the chat.